Thank you very much. Please, we take the national anthem and we will discuss it. Thank you very much. We have to take our seats. Thank you very much. Vice Chancellor, distinguished ladies and gentlemen, we are here in the 11th Inaugural Lecture. Welcome to this event. I am the Vice Chancellor from the State University, Professor Ayush Mandela Ati, the Deputy Vice Chancellor of Administration, Professor Underdeveloped, the Deputy Vice Chancellor, Professor Sani Ahmed Yauta, the Registrar, Dr. Abubakar Aliu Bafeto, the University Librarian, Dr. Henry Mena Abare, the Bossa, Mr. Jefaniah Shehu, Chairman of the University Ceremonies Committee, Professor Mohamed Gurama Duku, and members of the committee, the Vice Chancellors here present, the Vice Chancellor of Federal University Kashere, Professor Umaru Pati, then the DVC, Professor S.L. Keller, the inaugural lecturer, Professor Kennedy Poloma Yoriyo, provost, deans, directors, present, heads of departments, distinguished professors and members of the Senate, staff of the university, the wife, of course, of the guest lecturer and family members present, students, gentlemen of the press, ladies and gentlemen, you're welcome again to this great event. This is Gombe State University. We are primus inter pares. We are first among all of our equals. And in the spirit of Gombe State University at 2004 to 2024, we welcome you to the Center of Excellence, where for years we have dispensed excellence, we have supplied human manpower, and then we have provided community services to the university community. You're welcome once again, and on this note, I want to respectfully invite the chairman of the organizing committee, Professor Muhammad Guramaduku, who will come for the introduction of the reasons why we have gathered here. Please, you're welcome, Prof.
The Vice Chancellor, Gombe State University, Professor Ali Usman El Nafati, Principal Officers of the University, the Visiting Vice Chancellor, Federal University, Kashere, and members of his team, including the Deputy Vice Chancellor Academic, members of the Gombe State University Senate, the speaker this afternoon, the professorial inaugural lecturer, Professor Kennedy Yoriyo, and his wife, and members of his family, distinguished ladies and gentlemen, let me stand on the established protocol. Vice Chancellor, ladies and gentlemen, we are yet here today again, though there is a somber moment that is we are filled with in this university, having last week lost the first inaugural lecturer in this series, in the person of Professor Ibrahim Waziri Abubakar. May Allah have mercy on him, and may his gentle soul rest in peace. Amen. I believe the Vice Chancellor will also make some remarks pertaining to this great loss of our colleague, our friend, and a member of this great university. Mr. Vice Chancellor, ladies and gentlemen, like I said, today we are going to witness the 11th Inaugural Lecture from Professor Kennedy Poloma Yoriyo, a professor of applied parasitology and entomology from the Department of Zoology, in the Faculty of Science of this university. His is going to be the first from his department, and I think is also making history, and he is going to discuss this afternoon on the paper. His lecture is entitled "The Lady Mosquito, which underdeveloped and kept Africans in a poverty vicious cycle." I'm sure from the title we can project what we might expect. So, ladies and gentlemen, may I invite the Vice Chancellor, Gombe State University, Professor Ali Usman El Nafati, to come and make his remarks before we get to the main business of why we are here. Mr. Vice Chancellor, sir.
The Deputy Vice Chancellor here, Vice Chancellor Administration, and Vice Chancellor Academic, visiting Vice Chancellors, Vice Chancellor of the University Kashere, Professor Omar Pate, and the Deputy Vice Chancellor, Professor Keller, principal officers, other principals of the university, other universities here, deans, directors, heads of departments, the chairman of the ceremonies committee, Professor Wame Grama, other invited guests, and of course our dear lecturer for today, Professor Kennedy Poloma Yoriyo, his wife. Ladies and gentlemen, and my dear students, good evening. It's my pleasure to welcome you all to this 11th Inaugural Lecture. It has been a tradition of this university that we have this Inaugural Lecture delivered on a monthly basis, at least probably for the last 9 or 10 months. And I hope that this tradition will continue to be maintained. Today we're going to hear the journey in the study of mosquitoes by Professor Kennedy Poloma Yoriyo. Let me crave indulgence of the audience. On the side note, to also remember our colleague who passed away just about a couple of days back, Professor Ibrahim Abubakar Waziri. Professor Ibrahim Abubakar Waziri, he was one of the pioneer staff of this university. He joined this university in about 2005 or thereabout, and he served in many capacities in this university. Along the way, he became the first professor of this university. And of course, he also served as the director of the School of Basic and Remedial Studies. Thereafter, he also served as the Deputy Vice Chancellor of this university. He also, after his tenure as Deputy Vice Chancellor, he served as the Dean of the School of Graduate Studies. Thereafter, he moved to the Faculty of Art and Social Sciences, where he had been the Dean up to his time of demise. He delivered the first inaugural lecture in this very hall about 1.5 years back. And of course, it was a very historical moment at the time he delivered that inaugural lecture. What it served as an incentive and encouragement for other professors to come forward and deliver their inaugural lectures. And almost in that time, we have tried as much as possible to see that all professors have been put on the timetable for the delivery of their inaugural lectures. We pray may Allah subhanahu wa ta'ala forgive his shortcomings, accept him in his rahmah, and reward him with Jannah al-Firdaus. Part of the immortalizing Professor Ibrahim Abubakar Waziri, The manager and, of course, also the council has approved that one of the lecture theaters will be named after him to immortalize him. So, ladies and gentlemen, on this very simple note, let us also pray for him and observe maybe so few 1 minute silence in honor of our late colleague, brother and friend, and founding member of this university. 1 minute silence, please. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اللهم صل على محمد وعلى آله كما صليت على إبراهيم وعلى آل Amen. So not to take so much of your time, this is my pleasure that all of you pay attention and listen to our dear lecturer who will tell us more about his work in line of Mosquito and whatever he does. And I think it's something all of us will have a very important take-home message, as all of us have fallen one time or the other victims of malaria, which the lady malaria is responsible in spreading. Thank you very much, and good evening.
Thank you very much, sir. Mr. Vice Chancellor, sir, while you were delivering the opening remarks, attention has been drawn of the presence of the immediate past Vice Chancellor of the University of Maiduguri, Professor Aliyu Shugaba. You're welcome, sir. You're very much welcome. You're welcome, sir. You're welcome, sir. Distinguished ladies and gentlemen, at this moment, I will invite the University Orator, Professor Isaac O. Ediba, who will be coming for the citation on the inaugural lecture. You're welcome, Prof.
The Vice Chancellor, Professor Aliyu Usman El Nafati, Officer of the Federal Republic, the Chairman and distinguished members of the University Governing Council, the Deputy Vice Chancellor Administration, Professor Danladi Umar, Deputy Vice Chancellor Academic, Professor Sani Ahmed Yauta, the Registrar, Dr. Abakar Bafeto, the Librarian, Dr. Henry Maina Abare, the Bossa, Mr. Jefania Shehu, the Chairman, University Ceremonies Committee and Dean, School of Postgraduate Studies, Professor Muhammad Gurama Duku, Provosts, Deans, and Directors, Heads of Academic Departments, Professors, and other University Senate members, visiting professors, Professor Umar Pati of Federal University, Kashere, and his lieutenant, the Deputy Vice Chancellor Academic, Professor Kela, the visiting professor from University of Maiduguri, our dear postgraduate and undergraduate students, ladies and gentlemen. I have the singular honor and privilege, with the authorization of the Vice Chancellor, to render the citation on our brand new inaugural lecturer, Professor Kennedy Poloma Yoriyo. Professor Kennedy Poloma Yoriyo was born on the 20th of June, 1968, in a village called Putoki in Degri, district of Balanga local government area of Gombe State. He attended Putoki Primary School, where he obtained his first school leaving certificate in 1979. He later proceeded to Government Science Secondary School, Toro, where he obtained the senior secondary certificate in 1984, and then went to the famous School of Basic Studies, SBS Zaria, and subsequently ABU Zaria, where he graduated with Bachelor of Science in Zoology, the Department of Biological Sciences, in 1991. After the mandatory NYSC in 1992, he was employed in the then Bauchi State Ministry of Education. While working there, he enrolled for the master degree in applied parasitology and entomology, Abubakar Tafawa Balewa University, Bauchi, where he graduated in 1996. Upon deployment to Gombe State, he worked with Government Day Secondary School, Utoki, and Government Science Secondary School, Gombe, as a biology teacher. Professor Yoriyo was one of the pioneer staff in Gombe State University, where he was appointed as an assistant lecturer in the Department of Biological Sciences, Faculty of Science, on the 14th of October 2005. In 2009, he enrolled for his PhD at the Modibo Adama University, Yola, and graduated in 2015 with a Doctor of Philosophy degree in applied parasitology and entomology. On account of his scholarship and commitment in the area of administration and community service, Professor Yoriyo was promoted to the coveted and exalted rank of professor, having fulfilled all the internal and external requirements on 1st October 2021. Professor Yoriyo is a pioneer member of Mosquito Control Society in Nigeria, pioneer member of Pan-African Mosquito Control Association in Africa, member Entomological Society of Nigeria, member Parasitology and Public Health Society of Nigeria, member Zoological Society of Nigeria. Professor Yoriyo has supervised more than 50 undergraduate students, 20 master's dissertations, and now supervising 4 PhD students, one of which is about to be presented for internal defense. On leadership positions, he served as the director of SciWest in Gombe State University and was the pioneer head of the Department of Zoology. In addition to numerous departmental committees, he also served at the faculty level as the chairman, Faculty of Science Seminar Committee, chairman, Faculty of Science Examination Misconduct Committee. At the university level, he served in the following committees: member, Committee on Science Equipment and Regents; member, Reform and Revitalization of Science, Engineering, Technology and Innovation System; member, Committee to investigate illegal and fraudulent alteration of examination results; member, Review of Gombe State University Condition and Scheme of Service; member, Committee on Study Fellowship; chairman, ASU Strike Monitoring Committee, and also a pioneer ASU ESCO in the period between 2012 to 2014. Others are member Board of Trustee, Nigerian Montane Forest Initiative, member Board of Trustee of an orphanage foundation in Nigeria, chairman District Church Council Gombe 2014 Convention Central Planning Committee as part of community service, as well as chairman Northeast Conference of Girls Brigade Central Planning Committee in 2024. He is also the council chairman of the Aqua Theological College. Professor Yoriyo has won over 11 awards, some of which are the award by the Strategic Institute for National Resources and Human Development as Pillar of Nation Building in 2014. He also received award of the Association of Medical Laboratory Scientists of Nigeria, known as the Distinguished Award of Excellence for Indulgence in the Development of Medical Laboratory Scientists to Humanity in general in 2022. Professor Yoriyo won numerous research grants, among which is the first GSU research grant in 2007 on the role of insect pollinators in the Mambila Plateau, World Bank grant from 2009 to 2014 on malaria vectors insecticide resistance, Global Fund grant for 2020 to date on mosquito resistance monitoring and surveillance, US Presidential Malaria Initiative on Anopheles stephensis surveillance between 2023 to 2024, Bill and Melinda Gates grant on Anopheles stephensis surveillance in Nigeria on the 1st of August 2024, and Bionomics in 2018 and 2024. Professor Yoriyo is external examiner to many universities, among which is the Federal University Duse in Jigawa State, Nigeria Defense Academy Kaduna, and Ahmadu Bello University Zaria, his alma mater. Professor Kennedy Yoriyo has to his credit over 62 peer-reviewed international and national journals and has attended many international and local conferences. He is happily married to Wusa Kennedy with 8 biological and adopted children. May I invite him to please profess to this august gathering. Thank you.
The Vice Chancellor, the Deputy Vice Chancellor Administration, the Deputy Vice Chancellor Academics, the Registrar, the University Librarian, the Bursar, the Provost, Deans, and Directors of here present, heads of departments here present, the Chairman of members of the University Ceremony Committees, distinguished professors here present, other administrative and technical staff of the university, my family members here present, distinguished guests, and my dear GSS to all boys, the great Nigerian students of Gombe State University, my beloved wife and children, ladies and gentlemen. It gives me pleasure to say my journey so far up to this level. The journey started when I was a student in government secondary school, Ningi, where in the 3rd year, that is JSS 3, my name was shortlisted to be among those who will sit for science examination selection. Before then, you have the liberty to choose what you want to do, but in our set, we were selected to write an examination for it. And because I was so comfortable at Ningi, I didn't want to go for science school. And so I grudgingly sat for the examination. But to be candid and to be sincere, I wrote the exams because I was afraid of maybe they may punish me if I refuse to do it. And I wrote the exams very carelessly, I can say. I'm a footballer. I just go to the field, play my football, and then come and write the exams and go. So anytime I discover any question I don't know, I will happily skip it. And so, unfortunately for me, my name appeared. And so that marks my journey to be a science student in government science secondary school, Toro, which was a special school then. And then from there, I began my career as a scientist, and I moved to School of Basic Studies and later Department of Biological Sciences in the Ahmadu Bello University, Zaria. Something happened again. When I was in my final year, my seminar supervisor gave me a seminar topic to write on. And it was on pyrethroid insecticide. The word was very, very odd to me. It's like the first time I was hearing that word. And so I rushed to him to change the topic for me, but he refused. He said, I have to write on the pyrethroid insecticide. Unfortunately enough for me, it wasn't the internet era where you can just Google and find your information. You have to go through the rigor of cataloging and whatever before you can get information. So I managed to script and write something on it. I now on my project topic, I was allowed to choose the topic I will write on. And kindly enough, my supervisor then, Professor Vincent Oposa, I can remember very well, he was on sabbatical in ABU Zaria, but a staff of University of Jos. He said, I can bring any topic I want to write on. And so I jumped on schistosomiasis in school children in Funtua. I can remember my topic very well. I wanted to be a parasitologist. Now, little did I know that the component that Dr. Alonge gave me in the pyrethroid insecticide was supposed to be part of my combination. And that made it a complete topic of my applied parasitology and entomology. So what is parasitology and entomology? That's my discipline. Parasitology is the study of parasites, while entomology is the study of insects that transmit those parasites. So you have to study the two to be, let me say, to appreciate the fact very well. Otherwise, you may not find it. It's like a combined degree of two disciplines. So parasitology deals with the study of parasites, and then entomology with the study of insects that transmit those parasites, as we are going to look at some of the insects that are of my major concern. But I want to draw our attention here that before I castigate the lady mosquito that we are going to talk on, I want to draw our attention that insects generally are not to be neglected. Because they play a very major role in the society, in the environment. So if you just mention insects and you condemn them by their mere fact of being insects, you are getting it wrong, as you are going to see. Insects are the major decomposers of all organic matters of either plant or animal. For a plant to get the nutrient, it must be decomposed for insects, for the plant to get the nutrient, and so also the animals. The animals need to be purified in such a way that the insect serves as a purification agent. And also, insects serve as biological control agents in so many ways. As we can see in many cases, there are some fish organisms that feed on insects. There are fish organisms that feed on the larva of mosquito. There are some fish organisms that feed on so many other organisms. We have also found out that we have a mosquito species that do not bite but feed on the larva of other mosquitoes in this institution when we will enroll it today. Now, these are the importance, and we also use insects in textile industries. The clothes we wear are fabricated by the insects. We use their product. Insects are also medicinal. We use them in the medical field. Either the product or the insect, as we have seen. In the law firms, we use insects, forensic entomology. It can be detect when the death happens in a crime scene. By using insects, you can detect when that crime happened and the probable cause of the death. And also, they are used as food and a source of income for humans, especially in this hardship condition whereby it's too harsh to balance your diet. So you can easily go into the bush and collect insects and eat them. I know Prof. Sir from Maiduguri will bear me witness that I'm really saying the truth, because we do make them even for commercial purpose. Yes. In warfare, in the army, insects are very, very important in warfare. In 1937, Japan infected houseflies with cholera and sent it to China and caused a highly destructive effect. Also in US, they infected mosquitoes with yellow fever and sent it to Soviet Union and caused a highly disorganized and destructive their camp. So you can see that when you, as an entomologist, you can be employed in the army, in whatever field, and raise the mosquitoes, infect them, package them in a specialized bomb, and send it to your target. And they get destroyed. Anytime I'm teaching this to my students, they will ask, sir, but is this one not wickedness? I say, okay, it depends. If you are fighting with your enemy, do you select the way he will die, or you just want him dead? So it depends on how you look at it. If you select the way you want him to die, then you can choose that. Also, in defense surveillance, presently a drone called Skater, which looks like a dragonfly, has been developed. And the work of this drone is to spy any area, any battalion, so that all the information is now linked directly to the control room of the opponent. And for that reason, you may think that it's just an insect flying, and you discover that it's more than that. I could remember there was a time Professor Madi in medical college called me when, during the heat of Boko Haram, there were soldiers camped in the Nafada side, and they experienced a bite of housefly. And so Professor Madi called me and said, this is the complaint of these soldiers. What do I do as an entomologist? I described the insect for me. He said, yes. How did I know? Because that insect normally used to bite only strangers. If you are a stranger in a place, it will patronize you very well. And so when he brought them, he discovered that I told him what to do. He said, is that all? I said, yes. But Prof. Keller, who is working on tsetse fly, will tell you more about it, because the disease that transmit is not very common here. We now can say that they are just biting it for just maybe detecting that you are a stranger, and so let me tell you that welcome in our village or in our town. So, and also for ecological stability, for you to have a very well stable ecology of ecosystem, you need the insects. Pollination activity. In US, they generate about 57 billion annually on pollination services, not pollination activity, pollination services. That is to say, you just keep your beehives, and the farmers around there will pay you money for the services that the beehives is pollinating on their crops. And they generate up to 54 billion. In addition, you will harvest your honey. That services is just for the pollination services. Just like Professor Halima said in her inaugural lecture, that plants evolve with insects. Yes, that is true, because 80% of plants depend on insects for pollination. So you can imagine if there is no insects pollinators, what will happen? And also for seed dispersal, for them to disperse, for seed to be dispersed, about 150 species of insects of trees depend on seed dispersal. Dr. Babale will tell us more when it comes to dispersal. Purification of environment. It purifies, especially water system. There are some insects that if you see them in a water body, you know that that water is clean. You don't have to doubt it. Yes, I know Professor Danladi will tell us more about it when it comes to his own lecture. Now, for this ecological stability, therefore, we need the insects. Now, scientists have even went further to compare the insects and human beings, which one is more important on the face of the earth. And they say that if you are to remove human being on the face of the earth for 100 years, the earth will collapse and nothing will work again. The earth, if you are to remove human being on the face of the earth for 100 years, the world will function very, very normal. Nothing will be in a hitch. But if you are to remove insects on the face of the earth for just 50 years, the earth will collapse because nothing will work. Everything will cease to work. So that is how important the insects are. Now, the lady mosquito. Why lady? There is a saying that what a man can do, a woman can do better. That is very pronounced in the life of mosquitoes. In fact, in their own, what a man cannot do, a woman can do it perfectly. From here you can see this is the lady mosquito taking the blood from humans. It is only the lady mosquito that takes blood. The males don't. Now, this is the male mosquito. Sometimes they used to wonder, how do you identify males from female? Even my children, when they come to the lab, they can identify this one perfectly for you. Now you can see them. The one taking blood is the female, the other one is the male. The male do not even bite humans. They feed only on nectar and dew, while the female feed on nectar and dew plus blood when they want to lay eggs only, and not to cause harm to you. They are also struggling for survival. They want to lay eggs to continue with their life cycle. And this is the feature of the male and the female mosquitoes, Quilicin and Anopheles, and then Culex and males, Culex and Anophelines. Now, for you to understand the lady mosquito, you need to understand the life cycle very well. Otherwise, you'll get it wrong. As I said, the female mosquito is the only one that takes blood. And he is so greedy that when he is taking the blood, he will even be cheating the blood. He will be taking it, as you can see in this picture. He will take it to nonsense. And when they take this blood, they will go and find a place and rest so that the blood will digest and it will be like converted to egg so that there will be egg production. That is the resting stage. Now, these two stages are the stages that we will come back and discuss on the control measures of mosquitoes. Now, from the development, from the resting stage, they go to the breeding site and lay their eggs, as you can see them, and then the larva will emerge, and then pupa, and then the adult again continues. Now, In the life cycle of the mosquito, a mosquito can survive ranging from 2 weeks to 3 months. In the laboratory condition, they can stay up to 6 months. So therefore, a mosquito that can only stay for 2 weeks throughout its lifetime will not be able to transmit any disease, because before the disease completes its life cycle in the mosquito, it takes about 10 days. I will explain that one also later. Now, the adult female will mate only once in her lifetime. The adult female mates only once, and we call it rape. The moment the females are hatched in the field, the males will now go and rape them, and one rape is enough for them to produce eggs throughout their lifetime. No any other mating again. That's why I said they are very struggling. They don't bother themselves in the courtship behavior at all. They are out for business. They need blood meal to lay eggs. And after laying the eggs, they can also lay it again without mating again. And then we have this, they produce larval instars, the first, second, and fourth larval instar. This is the larval instar of an anopheline mosquito. This is the larva of a Achilles mosquito. And this is the larva of Aedes mosquito. Sometimes they ask me, how do you know, how do you differentiate? Now, anybody can differentiate it now from here. You can see how they differ. So if I send my collectors to bring larva, if it's Anopheles, they know. If it's Culex, they know. If it is Aedes, they know. And then this goes to the pupal stage, and the whole process takes 7 to 8 days for egg production. Eggs can be dormant for even up to a year, waiting for rain to surface. Now, the parasite. As I said, I will dwell on 2 parasites, the Plasmodium and the Microflaria. These are all transmitted by the mosquito, and some viral diseases. We have the Onyonyong virus, the Rift River virus, the dengue fever, the yellow fever, all are transmitted by the mosquitoes. So now, these 2 are of importance because of what I'm going to say. The gametocyte stage is ingested by the female, and this develops to zygote and to oocyst and to sporozoid. I capitalize gametocyte and sporozoid. Unless it is the gametocyte stage that the mosquito met in your body, even if you have malaria and he bites you, he will not be infected. Unless it is the gametocyte stage. And unless it is the sporozoic stage, even if a mosquito bites you that is infected with sporozoid, or that is infected, he will not transmit it. So it must wait for the cycle of sporozoids to come up before transmission can take place, and that lasts for about 10 days. And so a mosquito that spends only 2 weeks, he will hardly transmit the parasite. Now, and that, sometimes the chison goes to the red blood cells, which burst the red blood cells. The bursting of the red blood cells can be maybe in 24 hours or maybe 72 hours, depending on the Plasmodium parasite in question. Now the other one is the Microflaria. The Microflaria is a nematode, is larger in size. It's nocturnal in behavior. It's only circulate in the night. So any mosquito biting you in the night will hardly transmit or pick the larval stage of Microflaria, and he will not be infected because the Microflaria is not circulating in the blood system. It must wait for like nocturnal period around 2 p.m. or so before they can get it and transmit it. Adult can develop for 3 to 15 months. In lady mosquitoes, with infective larva 3 only can be infective. Otherwise, it must wait for 3 months for the larva 3 stage to become infective for transmission. And one funny thing I want to tell us here is that if the mosquito sip in a lot of microflaria, the microflaria are larger in size. It can even burst the mosquito and kill it there. So you can see the dangers associated with the transmission of lymphatic filariasis, which we are going to see later. Now, the transmission. As I said earlier, the mosquito, if a virgin mosquito that has not bitten anybody comes to bite you, don't worry, he's just taking blood. He is not transmitting anything. The mosquito don't have any disease in them when they are coming fresh on the field. That's why you can see us feeding them with our blood here. So, when they come, it must be an infective mosquito before he transmits the disease. Otherwise, he will not. And it must be the gametocyte stage I mentioned. If the gametocyte stage is not there, then the mosquito will just take his blood and he will not be infected. And for the microflaria, if it is not the laboratory stage, he will just take the blood and the mosquito will not be infected. So he will continue his biting without the infection. So the nocturnal periodicity in filariasis and the bursting nature of gametocytes in blood of humans or in their saliva. And one thing that is very funny here is that when mosquito is biting, it is sucking. It's not a two-way thing. It's not vomiting in. It's not regurgitating. It's sucking. So it's not that he vomits it, but the Plasmodium parasites are flown with the blood, with the saliva. So on the process of sipping the blood, the saliva is meant to make the blood not to coagulate so that he will take as much as possible. So that at the moment he removes the proboscis, then the parasite can get in. So in most cases, the microflaria don't have the chances to do that. Now, the breeding of mosquitoes. That is, Mr. Chairman, sir, in my field, in my stay in this university, I have been involved in breeding of mosquitoes since 2009 to date. I have been raising different generations of mosquitoes. In almost all the local governments, with the exception of, I think, Duku and Kaltung and Yamal Tudeba, that I have not yet touched. But in all the local governments, we have their records. And I think I can guess why. It's because maybe if I combine Nafada and Duku in my research area, I will end up settling quarrels and not doing the exercise. Now, the collection of larvae is done, and it is done mostly in the rice field and also in any water body collection. Now, we take them to the laboratory and sort them out, and we rear them with our ingredient. We use the yeast and the biscuits to feed the larvae of the mosquito. Now, adults are fed with glucose, soaked in. When we come to the larvae, we sort the mosquitoes to make sure that they are clean. Otherwise, they will be eaten up by their copypus or other organisms. These are their feet. And in the adult rearing, it's one of my start feeding the mosquitoes with blood. So when they are fed with the blood, you will see them red hot, their stomach, just as you have seen earlier. And then you disengage. Then you provide them with where to lay their eggs, and they will now lay their eggs. From the laying of the eggs, you can now hatch them. You can maintain a generation of up to 10, 20 filial generation here and use what you want to use them for. In our case, we use it to test in insecticides that we are going to see them now. Now, in the lab, this is what we do. We sort out the adults from the larva, from the bowl. And we sort them, males separate, females separate. We don't need the males. So it's only the females that we feed them. And for the females, we feed them for 2 days to 3 days before they are tested with any chemical. Chairman, sir, in most of our activities, we were engaged in testing, susceptibility tests, testing of the insecticides. About 4 different classes of insecticides were used for the test. These were actually given by the WHO and the CDC, Center for Disease Control. Remember the pyrethroid I rejected in my undergraduate appears continuously in my research. That pyrethroid was the real class that was very effective from 2009 to 2014. It shows 100% efficiency. That is killing them within an hour. We subject this test for 24 hours, but the pyrethroid kills them within an hour. And then this research led to the implementation of IRS in Gombe State and in Nigeria, as we will see also again later. Now, as it is, the pyrethroid is resistant now. And this is because of the rampant use of agrochemicals that we use in our farms that are made of pyrethroid, which made the insects develop resistance to all of them. Now we only use primipos methyl to replace the pyrethroid. Now, in the susceptibility activity also, in the lab, as I said, we subject them into this WHO test tube and then monitor them on hourly basis and on 24 hours basis. And we take the results and record the mortality rate. And in the record of the mortality rate, we identify the mosquitoes up to species level. Before we are using a colonial kind of microscope, but it was giving us results. But now we have a very brand new digital microscope that can take both the video, the photograph, and whatever. And this was the microscope that helped us to discover the Anopheles stephensi. Now, after identifying them, we package them into an envelope tubes, each mosquito carrying a label. They can detect each mosquito from, let me say, from Liverpool, and tell us that mosquito number this from so-so village from there is this. And if we go back to that place, we will get the same result because we take the coordinates and every information of the result. Now, the pyrethroid resistance level in Gombe State in 2020, this is the result. From 100, it becomes 15 in Akko, 20 in Balanga, 22 and whatever. And then the primipos methyl has now replaced it. This is what we have. Now, in the country, this is the result of the pyrethroid. In the entire country, all the PIs, I'm the principal investigator of Gombe State. So all the PIs will harmonize the results and project it. And this is the reflection of pyrethroid in all the states of the country, with the exception of Adamawa, which is still susceptible. And reason we may not know. And this is the result for the primipos methyl that has been all over. Is susceptible in all, that is, it can kill the insects in all these areas. Now, we are left with resistant management. The major issue confronting malaria and lymphatic filariasis is resistant management. Because if you move to this insecticide, they go to the other one, as we've seen. Before now, it was DDT that has been effective, but it is now phased out. We come to pyrethroid, phase out. We are going to another one, resistant management. In Africa, there is a swift and widespread of resistance due to our agricultural activities and the way of life of Africa. We do things anyhow, and that is encouraging the resistance of all these insects in all areas. And our culture too, and way of life is also a factor because we go out, we stay for long in the night, we are beaten. So even if the direction is on indoor, you may be beaten outside. And so the way of life of Africans whereby we stay in a place for far late in the night is helping them to manage or to maintain or to be endemic in this area. A lot is being also spent on mosquitoes and treatments on a monthly basis. There is an estimate that about 5,000 is now the cost of treatment of any malaria incidents. And you can imagine if you have a family of 10, you can imagine how much you will spend because you will be spending a lot of money. And the minimum wage is not all that reasonable. It has hijacked everything, in fact, left it to the medical, maybe to manage your health situation. And one funny thing is, when you go to the hospital, they will say, have you eaten? You begin to contemplate on whether to eat or to buy the drugs because the money is lost, not there. No, the cost of treatment is a problem. Now, when you look at the cost due to man-hour loss because of this issue, we discover that about 80,000 is being lost per annum, and that is a huge sum of money. We have estimated IRS in Gombe in 2014. Our estimate was over 1.1 billion just for one cycle of the activity in Gombe. And so you can see how expensive it is to manage this resistant nature. Now, also, huge cost of production and distribution of nets is also a factor, and the utilization of the nets, as you will see later. In resistant management in Nigeria, this is what we have seen. In Gombe State, the resistance management is like multiple kind of resistance. In other states like Adamawa and other states with metabolic resistance, because we study also the resistant mechanism that the insect is developing to the chemical, so that we advise on what next to do. Now, the impact of my research on policy decision in Gombe and Nigeria. In all our policy decisions, in all our research activities, our organizer, that is the National Malaria Elimination Program, coordinates the activity, whereby all researchers, donors, and manufacturers combine together to disseminate. We, the researchers, we give out the research, while the manufacturers try to see how they can incorporate it in manufacture of nets and whatever, and the policymakers make sure that it is implemented. And that is what has been going on for net distribution and other activities in Nigeria. Now, IRS in Gombe State was done in 2009 to 2014, and in that case, our role was to sort of select the insecticides to be used, and it was pyrethroid that was used because it was effective. All we do is we also monitor the efficacy of the drugs, of the chemical that is being sprayed on the walls. So we go with all the spray houses with mosquitoes. We deposit the mosquitoes on the wall, wait for 1 hour, and then we remove them, come to the lab and monitor their mortality rate. And if a manufacturer claims that the effect can last for 3 months, we will start calling. All they are based on our recommendation. Each state have a specific, I can remember vividly, is Plateau has, they have to spend a lot in that process. This is on yearly basis, and state like Plateau, as I said. Now, in this lady mosquito out in the Anopheles, but the story is going, this intervention will work or not. And that is what the federal government uses in that area. They use our information in that area. Let me give us a result of our vector surveillance in Gombe. The result of our vector surveillance in the past 20 years of my stay in Gombe State has given us this. In all the states of the country, no state has ever recorded up to 5 different species. But in Gombe, we recorded Anopheles gambiae, Anopheles coluzzi, Anopheles arabiensis, Anopheles funestus, and kingi, Anopheles sabi, Anopheles paroensis, Anopheles malpulpis, and Anopheles rupipes. And the last, which is the newly discovered, the Anopheles stephensi. We have 10 species in Gombe alone. None of the states in the country recorded up to 5. We have 10 for now, and we are still counting because yesterday my technicians reported a new species, but I will not mention the name now. Because before we mention the name, we have to go through all the tests that we have confirmed before it. Just before we could confirm this Anopheles stephensi, we had to apply for grant. Over 20 million naira was used for only 40 species to detect these species. Now, in the newly discovered Anopheles stephensi, this was the first reported case in West Africa. It has never been reported before. And it attracted a global concern in Africa. It is a potential threat in malaria eradication because it is exophilic and exophagic. This species now stay outside and bite outside. The attention of WHO is inside. Now this one is outside. So, which means we are not getting it right. That is why we are still having the issue. And with the breakdown, with the discovery of Anopheles stephensi, we have advised now the world, WHO and Nigeria in general to look outward, which I will bring the suggestion here because it's an all-encompassing kind of study. Now, we have mainly concentrated on Indos, which is the Anopheles gambiae, and this species has been proven to be very highly anthropogenic. They rest indoors, they breed in selected habitat, and also they have, what if we have a new species has emerged? And true, that is the Anopheles stephensi. A new species has emerged that it has been there with us, we didn't know. And so Anopheles stephensi blend perfectly with our African culture. I say this because it bites outside and stays outside. When you are whiling your way time, eating your food, discussing with your family, it is there. He doesn't go inside for him to pick the dosage of chemicals that you deposit on the wall. No. He doesn't go inside to do anything. He will bite. If he doesn't get the blood of humans, he can feed on blood of animals. So he will maintain his life cycle without even getting you. So you can see how risky this species is. And it has been the species that is keeping us in a poverty vicious cycle because we don't know that something like that is happening, but it is there. We have been concentrating on the indoors, while the problem is both indoors and outdoors. Now, what is the big deal with this mosquito, Anopheles stephensi? What is the big deal? Now, the big deal is that this species is highly competent of 2 kinds of malaria species, and that it is highly transmit Plasmodium falciparum and Plasmodium vivax. And so it's keeping Africans into this condition. It's an effective urban vector. Other vectors are rural. This one is an urban because it can breed in even little containers that we have. So because of that, we need to look at it inward and discover that we tackle this problem very well. This is the spatial distribution in Gombe by local governments, and the Anopheles stephensi was gotten in village in local government, and this is the invasiveness of the Anopheles stephensi. It moves from the Asian country, first detected in Djibouti and now in Nigeria. And it is highly a competent vector, as I say. This is the Anopheles distribution in Nigeria. You can see how loaded Gombe State is with different species, including the Anopheles stephensi. And this is the new discovered Anopheline species that we snap with our own digital microscope, and is the one that we are talking about. Now, in this manner, I will briefly tell us something about my PhD work. I actually worked on ecological study of indoor resting mosquitoes in relation to malaria and lymphatic filariasis, where I studied the vector, I link it with the parasite, and also the behavior of the vector, resting behavior. Do they rest indoors or outdoors or what? And the type of houses they rest in. That is, we categorize the houses into three: thatch rooms, non-ceiling rooms, and ceiling rooms, and we discover that we have a high concentration in the non-ceiling room. The porous the house, the more the indoor resting density. And in fact, in most cases, you collect up to 100 blood-fed mosquitoes in one room, which is a very serious signal that we are really suffering from the bite. The man-biting rate, how many are biting humans? We also detected it, and we discovered that it is Anopheles 0.30 Anopheles man-biting rate and Culex 0.49 biting rate. And it is estimated that 0.01 is on the high side, and you can see 0.3 and 0.4. And now, human blood index. We also had to study the mosquitoes that we collected. Do they contain human blood or animal blood? If they contain animal blood, we don't worry. If they contain human blood, we study them. Now, and if it is human blood, now, what are they? We also study their infectivity. And we discovered that there is a species, Anopheles gambiae, which is all through Nigeria. It's 100% human blood, but its infectivity is 0. It's not infected. So, and that is the mosquito we have been concentrating on all through our time. So that means to prove to us that we are getting it wrong, because we are looking at a different direction while the havoc is in another direction. And who knows, the havoc is in the Anopheles stephensi that we have been experiencing. Now, in our result also, we also studied the prevalence of malaria in healthy-looking people. We discovered 34%, and for filariasis, we discovered 3.2%. We discovered that we have more of vectors of lymphatic filariasis, but low prevalence. High prevalence of malaria, but high prevalence. That is because of what I said earlier. When the mosquito is taking the blood, the protozoan parasites are tiny in nature. The moment they withdraw their proboscis, the likely chance that they enter is high, and then infection becomes faster. But for the nematodes, a mosquito can only sit up to 5. So the chances are that when he removes his proboscis, so he cannot get actually, the nematode cannot get the hold, and it will die on the surface of your skin. Mentorship. In my mentorship, Mr. Chairman, sir, I had the privilege to mentor within and outside the university. Abdul Malik is a PhD student who has completed his PhD. We have been working right from his undergraduate up to his master's to his PhD now. And he today He is a very competent one. We also have Ezra Abba. Right from his undergraduate, he developed the interest. We have been working on the resistance mechanism, and today he is also a PhD student. And let me tell you here that even if I'm not here, these people can do the work. I'm remembering Professor Ibrahim now. His soul rest in peace. Abdul Salam Yakubu is from Medical College. We are working on a gene, particularly Plasmodium falciparum. Is K13 gene is found in this Plasmodium falciparum. The effect is that they are resistant to the drugs we give. So if we have more of them, even with the drugs, you cannot get it right because you will take drug and come back again and say your malaria is still there. So we are working on this K13 gene to know if they are here. Abubakar Mohammed, also from FCE Technical, we work on malaria prevalence in Almajiri's children. We discover a high prevalence there, but the children don't show symptoms of suffering. They have very high immunity. That is another subject for another day. Amina Chula also from Ministry of Health, we worked on schistosomiasis, and Zainab Omar. Also, worthy of mention, Mr. Chairman, sir, is the nanoscience technology that is in place. With Al-Hassan Al-Khali from Yobe State University, we worked on nanoparticles that can kill specifically the mosquito species you want. And we extracted some extract, and we discovered that we have very good nanoparticles that are species specific. So in this, he is from Yobe State University. He's continuing his PhD. And our target here is on the outdoor approach now. Because on the outdoor approach, you are going to look at the larval stage, whereby we apply these nanoparticles to control this organism. We also have Idris Salisu, a volunteer-turned entomologist. He used to come to my lab. He wants to work on to learn what we are doing. And today he gains admission through Suleiman Sadiq from Bayero University, the one that won over $960,000. He collaborates with us here in the university because the grant he won, part of what we do is what he also does. So I approve him, and he has gotten a PhD fully sponsored overseas through that grant, which is also part of our research work in the lab. And then the list goes on, and so many in the field of parasitology and others. Elimination strategy is the method of control. Sterile male release, let me talk on that. What we do now is we sterilize the males, release them into the field. What is done in Singapore, to go out and rape the females. Once a female is raped, he is not fertile. He will not produce eggs. And that is the end of our lifetime. So that is the importance of sterile technology. The use of repellent, stated, is a new technology that was launched just last July. We had the conference and it was launched. This formulation, when you apply it into your body, it can last for 18 hours. No mosquito will come close to you because it will be exuding some gases, carbon dioxide, body odor, ammonia, urea, and whatever, and deceiving the mosquito to be moving to the opposite direction while you are in the other direction. So, and that is a technology that we just need to invite for now, because you can rub it, go to the class, read your books for throughout the time. Since it's 18 hours, you can apply it from 6 to 6, no problem. Now, the nanotechnology that we have now discovered is also another method of control that we can use. Yes, sir. In conclusion, sir, the scourge of malaria and lymphatic filariasis have overwhelmed us in Africa, and there is a spread of Anopheline species, especially in Gombe State. The discovery of Anopheline serpentii has further compounded the issue of Indo targeting. Now, our problem in this country is the lack of political will to drive home uh, our desires. And so therefore, it will make us to be kept in a perfect abject poverty cycle. Our recommendation here is that based on the findings above, we recommend that a holistic approach be applied for the control of mosquitoes. Don't look inward, look outward also. And nanoscience is there, which we are developing, which will help in that aspect. And also, promotion of StarTech technology, as I mentioned, and integration of mosquito control in housing policies and environment, and also policymakers to prioritize preventive measures and to integrate it into our research findings. And say, in appreciation, therefore, I will want to appreciate Almighty God for his protection and guidance for taking me to this level. And to my Vice Chancellor, sir, I lack words to say thank you because you have set the ball rolling. And today, all over the world are watching us now, what we are doing. Because I have some of my friends in the GSS Toro, some are in UK, are now listening to what we are doing now because they are interested. We say thank you, sir, for that. To Faculty of Science, you are like a family, just like Professor Ankara said. Everybody encourages the other. Everybody is interested in what the other is doing. And that makes us do more. Thank you. We appreciate you. To my former Vice Chancellors, we appreciate them, especially Professor Omar and then Professor Mahdi. Professor Mahdi was the one that initiated me since 2007. He gave me the first Gombe State research. From then, I will always be getting a grant on a yearly basis up to today. And he helped me to know how to manage the use of grants. Thank you. I appreciate him because sometimes he will come by 6 o'clock and meet me in the lab. And he will ask, Yoriyo, do you sleep here? I will jokingly say, I should be the one asking you, do you sleep here? My house is closer to the university than yours. How comes you are here by 6? So we will laugh over it. And to my ceremony committee, so we really lack words for your corrections, advice, and maybe let me say tolerance to us. Thank you very much, sir. And to my partners, the grantors, well, the National Malaria Elimination Project, the CDC, the USAID, the NIMA, Nigeria Institute of Medical Research, the Global Fund, and others. They are very wonderful. They are the ones that supported all this research. I say thank you. And Mama Malaria, you can see her one-time national coordinator of malaria elimination in the program. Our research director, Professor Adepoju, you can see him in one of our training. He graced the occasion. My entomology technicians, you can see them all here. Thank you very much. We appreciate you. We appreciate you so much. My teachers in the primary and secondary school, I appreciate you for making me what I am. My late parents, I say thank you. My research team members, these are the ones also here. I say appreciate you. We appreciate you. I cannot forget the security men. We always ask them, if my research collectors come with the mosquito larva, they'll say the security stop them because they don't have ID card. And I will say, connect me with them. And if they say, I say, please allow them in. As long as they have mosquito in their hand, that is their ID card. And they will say thank you. And today, they can identify mosquitoes. Whenever they come with mosquitoes, they say, yes, go in, they know it. They will call me and say, oh, see where mosquitoes are. Thank you. To my wife, my lovely wife, and my children, my family members, oh, you are very great. Thank you very much. Professor, the Dean, faculty, the Dean, the Vice Chancellor of Federal University, Kashere, and his Deputy Vice Chancellor, Professor Keller, has been my mentor all through my undergraduate. up to now, and he has been the one that has been mentoring me. Thank you, Prof. Thank you, sir. My Prof from my Dogori, sir, and Professor Grama, my friend, we have been together all through. Anytime Professor Grama called me, I will say, oh boy, thinking that because I said it with Grama, thinking that he is the one. Thank you very much. I really appreciate you, sir. Thank you, and may God bless you all.
Thank you very much, Prof. Thank you very much. Please, a round of applause once more for Prof. Thank you. Thank you very much. Thank you very much. Thank you. Thank you. Thank you very much. Distinguished ladies and gentlemen, permit me to inform you that all the inaugural lectures that had taken place in the university from the first, presented by led Professor Ibrahim Waziri, to the one just presented today, will be found on the website of the university. Thank you very much, Prof. The lady Mosquito had done enough. Maybe that's why the lectures too was late. Thank you very much, Prof. At this moment, I want to invite the Dean, Faculty of Science, Professor Hajjagana Hamza, who will come for the vote of thanks. And those on the sound system get set immediately after the vote of thanks. We'll take the national anthem as we leave. Welcome, Prof.
The Vice Chancellor, Professor Ali Usman El Nafati, the Deputy Vice Chancellor, Admin Professor Dalladi Mohammed Umar, Deputy Vice Chancellor Academics, Professor Sani Yuta, the University Librarian, the Chairman of the University Ceremony Committee, Professor Muhammad Burama Duku, the Vice Chancellor, Federal University Kashare, with his Deputy Vice Chancellors, Academic and Admin, the lecturer, the Senate members, and invited guests, thank you very much. Thank you very much for sparing your valuable time to come and attend these lectures. And also, this lecture is very important, particularly to the Faculty of Science, because it is third of its kind in the inaugural lecture series and first in the Department of Zoology. And the lecturer, thank you very much for this insightful talk. And also permit me to thank my brother, the former Vice Chancellor, University of Maiduguri, Professor Ali Shigaba, who has been here for us for 1 year on sabbatical appointment. Thank you very much, sir. So thank you very much, and bless you all. Thank you.
Thank you very much, sir. Permit me to remind you that we are leaving this hall in reverse order. The MERS, the Vice Chancellor, and members of the Senate will leave before we follow them. And again, to remind you that we will rise to stand while the procession takes place. The Vice Chancellor, sir, having exhausted all the items on our agenda, permit me to plead that we rise for the national anthem as we recess back in reverse order, please. Nigerians all are proud to serve a sovereign motherland. Our flag shall be our symbol, that truth and justice reign. In peace or battle come, and this we count as gain. To handle to our children of honor without stain. Help us to build our nation where no man is oppressed, and so the peace come to Nigeria may be blessed.